Good morning, ladies and gentlemen. Today I'm going to be showing you the basics of Multisim. Multisim is a circuit simulation software that is used throughout the world. This is going to be used in college if you go off to college and you do any electrical or computer engineering. Now, what this program does is it allows us to take a circuit that we would build in the real world and completely simulate it in virtual reality. It's pretty sweet. Now, what that does for us is it lets us test something out before we actually go out and build it. It saves us a lot of time by letting us do that test. Later on throughout the year, we're going to see there's some powerful tools that are actually going to reduce the amount of work we need to do for some of the later assignments. So we'll want to make sure we learn about those when the time comes. Now, the first things I want to show you are just how to set up one of our most basic circuits that we do at the start of the year. What you're going to want to do is you're going to want to come up here on the upper left side. You're going to see we have all these little buttons here underneath your save and print menus. All of these little buttons are going to allow you to grab different components that we use. To start off with, let's just grab a source because these are some of the most basic things that we have. Now, you're going to see we have a lot of different options in here. 95% of these options are going to go unused this year. We just simply don't have the time to talk about everything that's in here. As I said, this is used in industry. There's a lot that we don't have time to cover in this class that's related to real-world electrical engineering. There's a reason you need a 4-year degree. All right, first things first, we're going to grab a ground. If you don't know what a ground is yet, that's fine. You should just make sure you go back to some of our early assignments and PowerPoints and read through them. Next thing we're going to do is we've grabbed a source now, right? Even though the ground is not a source, it's part of a source and sink. So we're going to have ground, and we can just grab power. I'm just going to grab a VCC power supply right here. We can use VDD, VCC. The VCC is associated with TTL chips, which this will matter down the road. VDD is associated with CMOS chips. And we could even grab just a generic DC power source. We'll grab that one for now, actually. All right, we don't need another source for now, so I'm just going to close that. Now, one thing we're going to need one more component. I'm going to grab a resistor. You're going to see there's tons of basic components in here. If we just look through only just all the families here, all of them, we could just keep scrolling all day, right? You're going to want to use these little boxes to help check it. Don't go up to the top and just try to type in what you're looking for. If you can see by the name of the component I have right here, that's far too specific, and this does not have a nice autocomplete feature. Grab a resistor. I just grabbed a random one. You could look through that list, put it on your board. So now on my sheet, I have a 12-volt power supply, a 1 kilo ohm resistor, and a ground. The next thing I need to do is I need to connect them. Now, all you have to do to connect something is go hover your mouse over the very end of that component, click once, then go, and you can click anywhere else along the way to help you route and organize your lines, and just drag them around. Now, I would like to note that using just dragging components on top of each other will connect them, but is not considered good practice because it does not always actually connect the components. Multisim sometimes struggles with that. So what you should do is you should always drag lines between components when you're connecting them. I know that just worked when I did it there, but that's not going to be always what you experience. Now, I'll have more videos covering different aspects of Multisim, but for now, this should get you started with the basics. You have your source, your sink, and a basic resistor. The last thing that we can do in order to test things out and try them is that we can go over and we can grab a probe. We can probe for voltage. You'll see that we have different voltage and current probes up where I was just grabbing from. Now you might be wondering, why is this not showing us anything? Well, it's because Multisim doesn't actually simulate the circuit until you hit go. Hit play up there, circuit's going to start running. You're going to see down here that there's a timer that shows you how long your simulation's been running for. You can go up there and you can grab a voltage probe, and you're going to see, since this is a very basic circuit, oh hey look, there's 12 volts right outside that power supply before it drops through that resistor. When it drops through that resistor, it drops all the way to ground, which is 0 volts. Now that's not a very interesting circuit to look at. So let's try to give it a little bit more complexity. We're going to go and we're going to add another resistor. Now this resistor is sideways. I know I didn't mention it earlier, but if you want to rotate this resistor, you can just hold down the control button and press R. That rotates your resistor. Then you can go put it in place. And let's say I want another resistor somewhere in there. And just for good measure, we'll put one more in. This time I'll put a 600 ohm in. I'm just kind of making up these values. There's no real rhyme or reason to what I'm doing aside from that. Okay, so now we've got all these new resistors in there, and you're going to notice if I click on the edge of my old resistor, I now have a problem. It's not the same symbol, and it now takes that wire away from my old resistor. The solution to that is to get a junction in play. What I do is you hold down Control and hit J. It looks like nothing happened, but as soon as you move the mouse, you're going to see a small dot has now appeared under my mouse. Go ahead, take that dot, click it in place, and you now have what's called a junction. This is like a fixed point on your circuit that you can run wires to without running into major issues. You can see I can now drag wires off of that junction, and it's gone away now because I've used it twice. Sometimes when you use it as much as it thinks it'll be used, it goes away. You got to make sure you get the little dot tool as well, otherwise you will rearrange those wires. When you have the angly wire tool like that, that means it's going to let you drag and rearrange that wire. It's not what you want 90% of the time. Why they put it in there, I don't know. Some people like it. I just prefer to delete and remake a wire. All right, now we have a lot more interesting of a circuit. Let's go hit play and grab some of our meters. We can see at the very top there, right outside the power supply, we've got 12 volts. After we go through that first resistor, though, we've dropped a lot of voltage. We've dropped down to 2.9 volts. And with our probe tool from up here, we can read that. If I want to get rid of that tool, stop reading voltage, I can click Escape. I can go grab a current meter. See right here, I've got 11.4 milliamps going through that first channel. That's what's going to be coming out as well. This portion, that very first resistor, that's a series portion of the circuit. There's only one path through it. Now we should see some changes if we go and we look at the current flowing through the other portions. Ignore the negative sign on the current reading of negative 2.9 milliamps. Well, all that means is that we're reading it backwards. My arrow is just pointing the wrong way. I rotate my tool. We're going to do that because unfortunately this tool cannot be set up the way we would like. That's all right. Just ignore the negative sign. It just means we're looking at it backwards. Right? You can see we have different currents now running through the different branches of the parallel portion of the circuit. This should make sense. We had all of the same current flowing through this first branch, and now that has to split and be shared amongst the other resistors. The bigger the resistor, the lower the current's going to be. We can always use this idea to double check ourselves when we're doing our theory work. All right. That's pretty much all for the basics for now. I'll be providing a lot more videos on some of the other things you might want to do. Make sure you check out the video on printing because people have questions to ask about that throughout the year. When you're done with the simulation, make sure you stop it. All right. Thanks, guys.